Chapter 11, Section 3 in the 8th grade note-taking guide is entitled Solving Equations with Variables on Both Sides. One definition here, definition of a literal equation. That's an equation with two or more variables. Obviously, if we have variables on both sides, we have to have at least two variables, if not more. So that's, of course, why that definition fits in here. Remember, we're talking about solving equations, something we spent the better part of 2 years talking about. So we're going to be using all those rules of solving equations that we already know. The rules of solving equations tell us to keep variables on the left and to put numbers or constants on the right. And when I'm talking about left and right, everything is in relation to the equal sign. Whenever I want to move something to the opposite side of the equal sign, I do so by doing the opposite. And remember, I'm allowed to flip the sides at any one time should I need to do that. So with all that in mind, let's go ahead and look at 1a here. 4x plus 6 equals x. Okay, so the rules say keep the variables on the left. Well, as you can see, I do have the variable 4x on the left, and that's really the only thing that's good about this, because 6 is a number and it's on the wrong side, x is a variable, it's on the wrong side. So what I would be prone to do here is to go ahead and flip this around and rewrite this as x equals 4x plus 6. As you can see, when I do that, then I have the variable x on the left side of the equal sign, variables on the left, and I have the number 6 on the right side of the equal sign, numbers on the right. So then the only thing that's not so good about this is the 4x, which I'm going to have to move. Now, when I want to move 4x to the opposite side of the equal sign, which I do, I'm going to subtract 4x from both sides. Remember, I'm doing the opposite, and as far as the opposite here, that's all about the 4x, not this plus sign in the middle. The plus on the middle is stuck on 6. Think about this here, and you've heard me say this before. 4x is a positive thing. The opposite of a positive is a negative. Negative looks like subtraction, so I'm subtracting 4x all the way across here. All right, so I do that. That makes these go away, and so I've got x minus 4x, which is negative 3x, and it equals this guy 6. All right, a multiplication equation to be solved by division. And as you can see, looking at their work that was pre-printed, it's not anything different. It's exactly what we were going to do here. We're going to divide both sides by negative 3, because now I'm going to isolate that variable, get him all by himself on the left side. Remember, when I want to move something to the opposite side, like the negative 3, since it's a number, I'm doing the opposite. It says I'm multiplying by negative 3, so the opposite is dividing by negative 3, which is what I'm doing. And when I take 6 and divide it by negative 3, I end up with a result of negative 2, which is exactly what you can see. The suggested solution there is, even though they took a different path to get there. All right, let's go ahead and take a look at number 2 here. Kind of a long problem. They've got lots of stuff here, but all we're going to do is consolidate this and undo what we just did. It's not anything different. We've got 10z minus 15 minus 4z equals 8 minus 2z minus 15. Now, as you can see, what they've done here first is they've consolidated what they could. They combined the like terms, which is something you're familiar with because we just did that in Chapter 11, Section 1. On the left side, they've noticed they've got the 10z and the 4z, and they can put those guys together to make 6z. Now, if you're wondering why I didn't do the opposite there, the reason I didn't do the opposite there is because I didn't move anything to the opposite side. They were on the left side. They're both still on the left side. They've just been consolidated. So I came up with 6z by doing 10z minus 4z, exactly what it says. On the right side, they consolidated the integers by doing 8 minus 15, same approach. And that's where they came up with this minus 7. This minus 15 on the left and the negative 2z on the right, I didn't consolidate those with anything yet because I haven't yet, nothing for me to consolidate with. I need to shift those to the opposite side, which is where they're going to go next here. All right, so we're going to send this 2z, the variable things, off to the left. As far as moving that, I'm adding it to both sides. Look, it's got a negative here. The opposite of a negative is a positive, and positive looks like addition. So I'm adding 2z to both sides. The 15, being the integer, is going to have to go over to the right side and join 7. And I'm adding 15 to both sides, again, me doing the opposite. And when I do that, I end up with 8z equals 8. And then it's a matter of me simplifying that. Well, of course, this is a multiplication equation. And even if I do it backwards, I still am going to end up dividing by 8 here. 8 divided by 8 changes into 1. So z, the variable, equals 1. All right, let's go ahead and continue on here and take a look at number 3. It says Daisy's Flowers sells a rose bouquet for $39.95 plus $2.95 for every rose. A competing florist sells a similar bouquet for $26 plus $4.50 for every rose. Find the number of roses that would make both florist bouquets cost the same price. All right, so take a look at Daisy's cost here. You're going to spend $39.95 plus $2.95 for every rose, which is exactly what you can see they wrote here, $39.95 plus $2.95 for every rose. Now the question wants to know, when would that amount be equal to, which is why the next thing you say is an equal sign there, the competing florist that sells them for $26 plus $4.50 for every rose, which is exactly what this side says, $26 plus $4.50 times the cost of a rose, or $4.50 times the number of roses. So we're going to solve that equation, and since they're asking me when are these two things equal, that's of course again why it's an equal sign and how I'm going to end up solving the equation here. Now, as far as solving this goes, this is again a little bit backwards. I would not tend to solve this like this. Not that the order needs to be flipped, but they're sending numbers to the right side of the equal sign, which I'm not really, or the variables to the right side of the equal sign, which I'm not too fond of. As you know, I would be sending variables off to the left here because variables belong on the left side. Remember, the reason we do that is because of inequalities. We want to set up these so they look like our inequality statements, because in our inequality statements, when I put the variable on the left side, the shading, when I make that inequality, will match up with the same way the inequality sign points. So I would be prone to subtract 450R from both sides here. And when I do that, the 295R minus the 450R is going to change into negative 1.55R. And then as far as the numbers, they're going to go to the right. So I'm going to send $39.95 over to where 26 is right now. And again, I'm doing the opposite to move it to the opposite side of the equal sign. So I'm subtracting. So I've got minus $39.95 there. That's going to end up giving me negative $13.95. Now, even though these are negative numbers, that's not going to be an overall problem, because realize when I'm about to solve here, I'm going to do negative divided by a negative, which is going to turn into a positive. That makes sense. I have to be selling a positive number of roses. I can't be selling a negative number of roses. So if I would have done this and I've said, oh, the solution is -7, they match up at -7 roses, it doesn't make sense. But here, the negative divided by a negative is going to turn positive, and it's going to work great. We're going to divide both sides by the negative 1.55 here. And when I do that, I end up finding that R is 9. So when I buy 9 roses from either Daisy's or the competition, I end up paying the exact same price for those 2 bouquets. All right, let's go ahead and take a look here at this example. It says Jamie spends the same amount of money each morning. On Sunday, he bought a newspaper for $1.25 and also bought 2 donuts. On Monday, he bought a newspaper for 50 cents and bought 5 donuts. On Tuesday, he spent the same amount of money and bought just donuts. How many donuts did he buy on Tuesday? All right, so what we can solve right away here is the cost of 1 donut using the Sunday and Monday information. What it says here initially is that he bought a newspaper for $1.25 and 2 donuts. So the Sunday amount is $1.25 plus 2 donuts, which they've represented as $1.25 plus 2D. They want to know when is that going to be the same as either of the days, but they went with Monday next, that he spent 50 cents on the newspaper and 5 donuts. So 50 cents plus 5D, which is what you see on the right side of the equal sign. So we're going to solve that equation, and that's going to give me the cost of 1 donut. Now again, the issue I have with what's pre-printed here is that they've sent the variables to the right and the numbers to the left, which I don't tend to prefer. So we can fix that, though. It's not a big deal. All right, I'm going to go ahead and subtract 5D from both sides here. When I do that, 2D minus 5D is going to change into negative 3D and then at the same time, I'm going to send numbers to the right by subtracting 125 from each side. And when we do that, we end up with negative 75 cents, or negative 0.75. So I want to know when negative 3D would be the same as negative 0.75. And even though we've got a different multiplication and division happening there, it's the same net effect because the negatives end up canceling out, and we end up finding out that the cost of a donut is 25 cents. Now, that helps us because now we know what the cost of a donut is. Now we're going to go on and take a look at Tuesday. He spends the exact same amount of money on Tuesday, but he only bought donuts. Now we figured out that at 25 cents, he's spending $1.75 each day. We can do that a couple different ways from Sunday and Monday, but it doesn't matter which way we do it. He's only spending $1.75 each day. Remember, the question says he spends that same amount each day. That's how I know that. So at 25 cents a donut on Tuesday, if he is just buying donuts and is spending $1.75, all right, then what we can deduce here is that he had to have bought, how many times can I make 25 cents going to 175? Obviously, the solution there is 7. So he ends up buying then, as a result, 7 donuts on Tuesday. And that's great because now that I know that, that's the answer to the question, because the question is clearly asking me how many donuts did he buy on Tuesday? Well, he bought 7 donuts if he's spending $1.75 each day, which based on our mathematical calculations is exactly the amount he's spending every single day. All right, now this question is a little bit different. It says the equation t equals m plus 10e gives the test score t for a student who answers m multiple choice questions and e essay questions correctly. Solve the equation for e. Now, we don't usually do questions like this. You're not solving the equation for e in that you're going to find a number value for the solution. It's not going to be e equals 6, or e equals 9, or e equals negative 1.2. You're going to set e equal to all the other stuff. So you're going to do this just like you're doing a regular equation, opposite side do the opposite and all that, but all it's going to be is it's going to be e equals everything else. It's not going to be just a finite number, it's going to be everything else in the question is going to end up on the other side of the equal sign. So take a look, we've got t equals m plus 10e. Now I'm solving for e, this variable e. So I want to go ahead and get him all by himself. Well, think about it. When we solve an equation, it's always like x equals this or j equals this. So if I'm solving it for e, that's the thing that's going to be on the left side of the equal sign. And if he's going to be on the left side of the equal sign, I need to go ahead and flip this around. So I'm going to rewrite this as m plus 10e equals 10. So everything else other than e has to get kicked over to the right side of the equal sign. Now we know the thing that's directly connected to the variable by multiplication always goes last. So the 10 is going to go last, which means m has to go first. So I'm going to move m by doing the opposite. I'm going to subtract m from both sides. M there is a positive. The opposite of a positive is a negative, and negative looks like subtraction. So I do that, and I've got 10e equals t minus m. Getting there, but now I got to get the 10 kicked out of the way because, again, I just wanted to say e. Well, this is a multiplication question now. So I'm going to solve that by dividing. Now, some of you are saying, oh, that's not going to be fun. That's going to be a lot of work there. No, it's not. There is no work to do. We're not combining these. We're not simplifying these. Our goal is to just get everything over to the right side. And I've done that. What I have here is my solution, fully simplified. That's as far as I can go. E equals t minus m over 10 is how I've solved the equation for e. All right, so let's go ahead and take a look at the questions at the bottom of the page there. In number 1, we've got 5x plus 8 equals x. Now this is, again, one of those questions that we could solve it like this, but there's more things wrong than there are right. The only thing that's really nice about this right now is 5x. 8 is a number, he belongs on their side. X is a variable, he belongs on the left side. So this is one of those questions where I would go ahead and flip right away to start here. And as I flip this around, it's going to say x equals 5x plus 8. Well, as you can see, now I have a variable on the left and a number on the right. The only thing I don't like is the 5x, because that's a variable thing and it should be on the left. So I'm going to go ahead and flip that around, move it to the opposite side by doing the opposite. That's me subtracting 5x from both sides. So I do that, and I've got negative 4x equals 8. And as you can see, what I have here is a very basic one-step equation to solve. It's a multiplication equation, so I'm going to solve that by dividing. I'm going to divide out by negative 4 all the way across. And when I do that, I end up with x equals negative 2. Now, number 2 is like an earlier question as well. There's a lot there. It's like question number 2 in the examples. There's a lot there. All they want us to do is simplify by combining our like terms and then do all the steps of solving an equation. So we've got 12z minus 12 minus 4z equals 6 minus 2z plus 32. So on the left side here, I've got these two z terms I can put together. So I'm going to combine the 12z minus 4z, and that's going to end up changing into 8z's. Again, if you're wondering why I didn't do the opposite, it's because they weren't on opposite sides. They were both on the left side, so I just put them together. Still got the minus 12, haven't done anything with that yet. And it equals, well, over here, all right, I've got this negative 2z. Well, I can't do anything with that yet, so that's just going to be negative 2z. And this 6 and 32, though, since those are constants, those can be put together here, those integers. 6 plus 32 is 38. And again, I'm just doing exactly what it says. I'm not doing the opposite side, do the opposite stuff yet. All right, so now let's send variables to the left. We've already got 8z over there, but 2z is going to join them. I'm going to add 2z to both sides. Again, that's me doing the opposite. 2z there was a negative. The opposite of a negative is a positive. Positive looks like addition. As far as 12, sending that to the other side. Again, me doing the opposite, so I'm adding 12 to both sides. So I do that, and I've got 38 and 12, which goes together to make 50. So I've got 10z equals 50. Right, that's a multiplication equation to be solved by division. So I would divide out 10 all the way across now here. And when I do that, z equals 5, which is the solution you can see they've already listed. All right, let's take a look at number 3 here. It says Marla's Gift Basket sells a muffin basket for $22 plus $2.25 for every balloon. A competing service sells a similar muffin basket for $16 plus $3 for every balloon. They want to know at what price point would those muffin baskets with the balloons match up. So for Marla's, said they say spend $22 plus $2.25 for every balloon. So plus $2.25 for the number of balloons. 22 plus 225b. All right, and they want to know when is that the same as, let me go ahead and fix that sign up there. It should be just an equals. When is that the same as the other guy? And what they tell us about the other guy is $16 for the basket plus $3 for every balloon. So 16 plus 3 times b. Solve that equation. All right, so we know how to do that. Variables to the left, numbers to the right. So 3b's got to go over to that left side, doing the opposite. So that means I'm subtracting 3b from each side. And numbers to the right, which means this 22 is going to get kicked over here. Again, moving it to the opposite side of the equal sign, so I'm doing the opposite. That's me subtracting 22. All right, so I got 225b minus 3b, which is negative 75 cents b, negative 0.75b. And I want to know when is that going to be the same as negative 6. All right, well, that's a multiplication equation to be solved by division here. So I'm dividing both sides by negative 0.75 here. So I'm going to take that -6 and divide it by the -0.75. Negative divided by a negative is going to change positive, which is great because it should be positive. It should be a positive number of balloons. That would make sense. And when I do that division, 6 divided by the 75 cents turns into 8. So at 8 balloons, the cost of the basket at Marla's and Hearst competitors will be exactly the same. All right, let's go ahead and take a look at this wrap-up question here. Helene walks the same distance every day. On Tuesdays and Thursdays, she walks 2 laps on the track and then 4 miles. On Monday, Wednesday, and Friday, she walks 4 laps on the track and then walks 2 miles. On Saturday, she just walks laps. How many laps does she walk on Saturday? All right, so on Tuesdays and Thursdays, it's 2 laps on the track. We don't know how long the lap is, so 2 times the number of miles, and then she walks a plain 4 miles, 2x plus 4. And it's got to be the same as what she does Monday, Wednesday, and Friday, which is 4 laps on the track. But again, we don't know how long that is, so 4x plus how many miles she just does flat, which is 2. All right, so I'm solving the equation for x so I can figure out how long the track is here. So, as I solve the equation for x, that's me knocking 4x off both sides. Why? Because I'm sending variables to the left, and again, whenever I want to move something to the opposite side of the equal sign, I do the opposite. As far as moving the 4, same issue. I'm going to subtract 4 all the way across here, because that's how I'm going to get that to the opposite side of the equal sign. So I do that, and I have -2x equals -2. Solve that out by dividing now, as you know. Doing the opposite because that's always how we solve. X equals 1. What does that mean? That's not my solution. What I now know is that 1 lap on the track is a mile. Now, how much is she walking each day then? Well, whether we go based on the Tuesday, Thursday figure or the Monday, Wednesday, Friday figure is irrelevant. But let's go based on Tuesday, Thursday. She does 2 laps on the track, and each lap is a mile. So the first lap is 1 mile, second lap is 2 miles, plus the 4 miles she does. That means she ends up walking 6 miles. And you would get the same calculation for Monday, Wednesday, Friday, 6 miles. We can prove it. 4 laps on the track, 1 mile each, 1, 2, 3, 4, plus the 2 miles is 6 miles. So she does 6 miles. How many laps then does she walk on Saturday? Well, remember, a lap is a mile. So if she's walking just laps and she's doing 6 miles, that means she has to be covering 6 laps. What number times 1 equals her total distance? 6. 6 times 1 is 6. So she's covering 6 laps on Saturday.